Hi, I'm Andrew Armstrong and welcome to the back office teardown lab. Here we have it, the Nombrex signal generator type 27. Now this thing has been in my parents' loft for as long as I can remember, and someone was rooting around in there this weekend and my dad handed it over, and he told me he bought this brand new in the 60s, and I can tell it's not been used. I promise you it can't have been used for decades and decades and decades. It's just been up there. So I don't really know how to use them. We made a Velleman kit, which was a signal generator kit. We did it, we played with it. My father tells me it's something to do with hi-fi. When you're testing hi-fi, you inject signals at different stages, you know, at the preamp, at the amp, and you kind of hear what goes along. I like how he's only put in 2 of the screws. So clearly been in and out of here a few times. But again, as I said, I remember it being in the loft for so long. Surely it can't have been brand new when you got it. How often would you have to change the batteries in it? Oh wow, look at that! So it even seems reasonably intact. I mean, arguably I think that panel should have been that way. It seems to have been that way, but I think it should have been that way because you'd want it to touch that, stop that shorting out. So this is a hammerite finish, by the way, boys and girls. That's not something weird that's gone wrong with the paint. There's a bit of rust there and some chipping, but this is actually called hammerite, and everything used to be painted with it. So I can see he's made some sort of battery bay here with this interesting 9 volts battery clip contraction. So it means I'll probably have to try to find a 9 volt battery. But before I do, let's have a look inside to see what else we can see. I think it's probably reasonably intact. You have very few components. You've got a transistor here, sorry, transformer. Transistor. There won't be a transistor anywhere on here. These are resistors. I've got actually packets of these kind of resistors if anybody's interested in some of them. There is a transistor actually right here. You can see them right down there, and that'll be your switches on the front for the mode selection. And then you have this, which looks like a variable capacitor. No, it's not. It's just another switch. Actually, look, this is the variable capacitor here. Look, see the blades moving in and out, offering different levels of capacitance. But this is a switch like you get in a multimeter, joining up all these different tuning things. So is it frequency? So, oh, it's the range. Look, so it's putting them through a coil, or like an inductor, and they're all different sizes to tune it all up. Well, I think that's it. We've covered it all. You could practically recreate one based on the knowledge I've just given you. So the only thing I think left to do is put a battery in it and see if we can actually get it to do anything. There was a loose thing on the front. You can see, by the way, this down there, just in there, boink, wobbling around, but I don't know, it's probably alright. Not much we can do about it. So we'll just pretend that's fine for now. But that looks like you might have to take the front plate off and literally solder it to the chassis. Someone has a brand new battery. That someone is me. Let's get that in there. So I'm just looking at the switches on this thing. Off, RF, mod, AF. Radio frequency, audio frequency perhaps? In fact, let's make sure it's off though. It's definitely off. I've made sure it's off, and this is a fresh battery. This snap does look a little bit dicey, but it'll probably be okay if I use this bit of cardboard toilet roll or whatever it was to compress it up. Quality engineering. Yeah, I think that will fall out. That's fine. I think let's just turn it over gingerly. Nothing came out? Good. So how do we actually know if this is doing anything? We can turn it on, we can play with it. I don't know. Well, it does say AF out on here, so I'm wondering if we plug this probe in, which I like is like an old TV aerial, and try to hook it up to a speaker, we might be able to hear something. I've got my pot noodle speaker on. I'm going to clip these probes. Oh, You can hear the pot noodle speaker crackling and popping there, ready. Right. We be connected. Let's turn it on. RF, mod, AF. I don't think I'm hearing anything. Got the oscilloscope on it this time, and it certainly appears to be pretty dead to me. I'm really not seeing anything, not even seeing noise. It's normally a bit of a giveaway, to be fair, when that happens. I think we'll have to get some contact cleaner on here. I want to make sure all these contacts you see actually are contacting, because we might be switching this, but if they're not actually making an electrical contact because they've got corrosion on them, then there'll be an issue. I can see already, for example, here, where I've just rubbed this side, look. That's the difference we're making, and that's without any kind of abrasive at all. It's time to see what we can see. I have the signal generator here, and you can see I've got various probes hooked up. One of them is this multimeter, but it's actually a digital storage oscilloscope, which you probably can't see. And the other is this pot noodles speaker that served me well over the years. So I'm going to set this up here. I'm going to turn the light off. Hopefully it's not too dark for you at home. It just allows me to see this screen. So I'm going to turn this on now. And I can indeed see some flickering on here. Not much. We're actually connected to this audio frequency output, and you can hear there is a bit of a noise. It almost sounds like a radio, as in I could have sworn I maybe heard a voice, you know, London calling. I'm going to play the range. Oh, there you go. So this is currently set to the mod. See it there, mod. I shall move this aside. Maybe we can get a little bit closer in on the zoom so you can see the oscilloscope, what I'm seeing. Okay, so you can see the trace now. I don't know what changed the frequency. Just probably a bad connection there. And now it's on the AF, the audio frequency, and actually we are on the AF output. So this is where you'd really expect to hear something. Again, I'm not sure if... Oh! That's a good strong signal now. This adjustment here doesn't seem to be doing anything, unfortunately. Let's go back to RF. We've got something there. It's coming. It says it's coming through 9 kilohertz on the scope. So not everything will be in the audio range now. So we're seeing a waveform on the screen there. It says 2 kilohertz. And then as I'm turning it this way, oh, it went up for a bit and then it went down. So now it's now 10 kilohertz, 5. I think the scope is just getting confused here. But yeah, I'm not quite sure where audio kicks in actually. So we might not be able to hear everything. having a bit more of a play, I'm pretty sure this RF connection is duff, because you can see as I'm wobbling this connector around, it's really going to town on that. However, it does seem that the audio one works occasionally. It does seem to be a switch issue. There you go. And looking at the schematic here, which conveniently actually has all of the parts here, you could replicate this whole thing. Shows the audio frequency side of things to be here, and really none of the RF circuitry should come into play, because when you switch AF or mod, that's coming through here and it's all going to town. It should show that this part here that leads to the RF circuitry, which I guess is the power rail, shouldn't be in there. So far so good. So let's work on this then. I really want to get this faceplate off, but we're going to have to get these knobs out to even have a chance. So I'm going to be very ginger and see if I can prise them up. Oh, there's a screw on them. Luckily I didn't pry it too hard. So that's handy. Crikey, that could have been dangerous. And as you might hear, I do have a frog in my throat. This is at least 1 or 2 days later. I can't remember when I started making this video. I think it was 2 days ago. And I've got progressively worse. Don't worry, it's not the COVID. It's just a cold. But I kind of feel it's ironic. You're not going out, you're not really doing anything, but you can still get poorly. And that's probably because of the children. Right, bear with me. I'm going to get these flathead screws out. I found a solution. I sharpened the end of a screwdriver to get in, because I don't have all of the various sizes you need in flathead. In fact, I can't even remember the last time I saw a flathead. So I'm just going to very carefully put all of the screws away, just on the understanding that it's going to be impossible to get any of these if I lose any. So that's the main faceplate, and then there are these smaller screws, which I believe go to the PCB and standoffs. So quite a lot to undo, but at least we'll be able to get the PCB out. And during my research, I actually found that this does use a particularly weird battery, which is a 9-volt, and this has obviously been adapted to use a standard PP3, and that's exactly what everybody else seems to have done, and wedging in also a bit of toilet paper. Now there are very tiny nuts and bolts on each one of those, so that's not particularly fun, but it does look actually like you should be able to get the board out. Yep, with a little bit of jiggery pokery. That's quite nice, isn't it? That little case frame. It gives me a chance to have a look to see how we can possibly solder this RF connection, which really is ducking and diving. And it looks to me from this angle, actually the center pin of the RF connector isn't connected, and it has come away from the top of the PCB, so I will need to undo that, but it does seem to be a bit easier now this is out of the frame to undo all these little nuts and bolts. Literally just undid the last one so the plate can come off. Look at that. That would be nice though, be able to give that a little bit of a clean before I put it all back together. Type M27, which that matches with the number on the thing at the front. So yeah, there's a couple of breaks here. I'm going to zoom in. It's pretty clear when you see it. Those two are broken, and it's actually broken from there too. They're not through-hole components because it's a single-sided PCB. Sorry, not through hole vias here, because it's a single-sided PCB. So I should be able to repair that pretty easily. I'm just wondering if there are ways, because you can see these were designed to support the connector more and give it a little bit more support, and they've obviously not worked. So I'll have a little think about that. So we'll solder it up and we'll see how strong it is at the end of that process. If it's good enough, we'll leave it. If not, I'll see if there's something we can do, maybe something with some adhesives. So a little bit of flux going on there. And by little, I mean fair old schmoz of it. Let's zoom in, get a better look. Let's get the soldering iron warmed up. And I'm just looking around on my desk because I think it's time for some leaded solder. We're not going to go lead free on this. It's definitely going to have leaded in it back in the day. do have a tiny bit of this left. So we're up to 378 degrees, so that should be good enough. So I'm going to first try to attach it back to this one pad that was still on the board, and that's fine. That's soldered actually quite nicely on there, and you can see it's already pretty firm. So now we're going to tackle this one here. Let's put that on there. You can have a look while I'm doing it. And we're going to go around this side. There is a weird blob there. What's that? It's either a component or someone's already had a go. No, just an old component. And what I'm going to do is I'm going to drag the solder out further on the track so it's like a humongous blob of it. And that should give it a lot more grip. That's nice. As long as the tin work still fits over the top, it should be good. And then we have this final one here. Let's get right into it. Gosh, the smell. It's got very old electronic smell. And anyone working on old radios and things will know it well. Woo! Stinky. But I think that's almost solved. Now we do have the one pin that was coming up through the center, through here. I would like to be able to get that, so I'm going to push that ring down. Don't know if you saw that. I made the solder molten and I pushed down, the whole thing dropped down. And what we can do, and I've done this before on my own designs, let's see if we can get in there, is you've got those little pins sticking up. If we're lucky, you can get a bit of a bend on them. And I'm kind of surprised they didn't do this originally. There you go. See that little bit of a bend? So there's going to be no damage on that. I mean, it's belt and braces. I doubt anybody's going to be using this in the future, but we could just go through and do the same on that AF socket. And while I'm at it, why don't I just touch up that joint? Make sure that's nice and fresh, and let's have a look at that one while we're here. That's looking pretty good, to be honest with you. And I can see, look, without the flux, it's definitely not flowing as nicely, but it is flowing. Imagine that after all these years, the old flux on the board, because you can see there's definitely been flux on here and it's not particularly clean, is still capable of working. Gosh, how old is this thing? It must be over 40 years, I'm sure. 40, 50 years? Crazy, isn't it? So before I put it all back together, I am going to have a quick look through here and we'll have another little test. And any solder joints that look dry, I'll touch them up. But honestly, they look fine. They look absolutely fine. And you can see right away it's made such a tremendous difference. If you look at the oscilloscope, you can see I'm adjusting the attenuation. That's going up and down now, nice and clearly. And as I change the frequency, you can see that moving right there on that display. And of course this was the different ranges, and as I click through those, I think what's happening actually is that we have to change the time base here. We might not be able to see the waveform of some of these frequencies, and I think that's what's happening. Yeah, that's fine. Just scope stuff. But look at that, yes. Let's put it all back together, shall we? Just cleaning this out before I put it all back together, but look how cool this is. There's a little detent ball in there. If you can quite see that. See that little bearing? Like a little ball bearing just bouncing around. It's a really good opportunity to get in here and actually just be able to squirt your contact cleaner straight into the side of these switches. Popping it all back together now. It makes me wonder though, that whole RF side, on how you would test that. And I'm wondering if you would have used a radio, like an AM radio. So we'll have to do something. We can certainly see it on the oscilloscope doing things on the ranges that the oscilloscope can display, but whether or not that's a good way of testing it, I don't know. It certainly seems from what I was reading that people are talking about the calibration and stuff on these and say how they were spot on. You know, they've gone through and they've serviced some of the components, for example, swapped out I don't know, some of the resistors or the transistor and things like that, but they found even after that it was still pretty much on calibration. So very cool. And I guess the calibration is defined by all those little, I guess they're variable capacitors, right, or inductors, and then once they're set and epoxied in like that, they're not really going to change. Putting all these standoffs on is definitely as fun as it looks. What a nightmare. But we're almost there. I've managed to get them all on pretty loosely. That way we can check that panel out first, flip it over. You can see it's nice and clean. That's looking pretty good, isn't it? And I was a little bit worried about our solder blobs being too high, but you can see you'd have to go really high to go higher than the standoff, so they're going to be nice and solid. We don't have to worry about them at all. Tighten it all up now. This is very exciting. So you might have heard while I was screwing it back together, the audio side's working nicely and clearly, and you've got the oscilloscope here and it's actually reading 162 kilohertz, and on the gauge here it's literally on 160, and as I move it up to 170 it's saying 172. So we can calibrate this now by just ever so slightly, if I can find it, loosening the screw here. And yeah, and I have to be a little bit cautious on this, don't I, because how the screw is on the other side. So what I'm going to do is actually I'm just going to unscrew this totally with the right screwdriver. That'll help. Okay, so now that's totally loose, and then I'm going to move this all the way around, so it's all the way around that way. I'm going to put this back on so I can adjust it. That's right, I've got some play. So now I'm going to turn this knob till the meter says exactly 160, so it's just about right there within the tolerance. It's actually flickering between, oh, it's 160 for all intents and purposes. It's 160, and then I'm going to bring that down just so it's right on top of it, and I'm going to lock that in with my fingers just to make sure it's not going to move at all as I tighten that grub screw. Yep, now we're nipped up. So I'm going to bring that back down to where 150 would be. Yep, and it's like 149, 150. It's just like flickering between the two. And I'm going to bring it right up to say 200. And it's again dead on. It's got a little bit of jitter. You can see actually from the trace here, it's got a certain amount of jitter. But I'll adjust it and read out what I'm doing. So we've got that on 200. I'm going to move it down to 190. So now we're on the 190. And now we're on the 180. So it's as close as you need, isn't it? It really is. And that, as they say, is that. So any boys and girls watching at home, what's the purpose of this and what would you do with this range? I'll just read out the ranges. So it's got 150 kilocycles to 425, it looks like, and 1.2 megs to 3.5, and then 10 to 30, 50 to 165. So I think it certainly sounds to me like something that would work, you know, be useful on a software-defined radio. You should be able to tune this and pick it up. In fact, I was just looking. I was only reading off ranges 1, 3, 5, and 7, and there are the ranges here that are going. Ooh, where's this one going? This goes to 340 something megacycles. So yeah, you got to play with this, just like an old voltmeter. But yeah, please let me know, like, share, subscribe, and I'm looking out for those comments. Thanks for watching.